AP Calculus AB Unit 4, review, corrective for the retest. So this is what you should do minimum to prepare for the retest. You should probably find some more practice with problems you know you have trouble with to make sure you're super ready to do it on your own. You should have tried all these problems already. Maybe even tried it as if it were the test after reviewing your test. See how you could do if you had to do it all at once without getting help. So secant and tangent lines, the slope, I'm only asking the slope this time. I could ask for the equation, so you just got to be on the lookout. The slope of a secant line, it's like a curve, and you have a line that connects to dots. So you're just trying to find the slope of that line, rise over run. And if you want to find the equation, you can use either point. So, we could probably calculate the first point. We could do this work separately first, just keep it nicer, neater. So that's f of 1 and f of 4. I want to find the y values. I go with these. It's going to be 3 times 16 is 48, plus 8 is 56. So the slope of the secant line would be f4 minus f1, or the other way around, or 4 minus 1. Just be consistent on the top and bottom. Rise or run. Just change y, change an x. So 56 minus 5, or 4 minus 1. This is really good to show your setups. 51 over 3. 5 plus 1 is 6. 3 goes in 6. So 3 should go into 51. And goes in 17 times. So that's the slope of the secant line. If I want the equation, then I'd use one of these points with this point slope form. Be done with it. Slope of the tangent line. Tangent line, we have these derivatives. So you got to find the derivative, f prime equals 6x plus 2, power rule, and then plug 2 into it afterwards. And so f prime of 2 equals 14. This is the slope of the tangent line. It's just the derivative. Now, if I wanted the equation, I'd have to plug 2 into this, get the x and y, plug that in. Find the equation of the tangent line. Okay, so this is the actual equation of the tangent line, so we need a point. We could start with the point first. Just plug the x in that you know, and get the y. All right, so your point is 4, 1. But we need the slope, so we need to do the derivative. Now, what I would suggest is that you rewrite this in something a little more easier to take derivative of. This is 2x to the negative 1/2. Now this is power rule. Y prime equals multiply by negative 1/2 in front, decrease it by 1. 2's cancel, still negative. You might rewrite it. That would be negative 1 over x to the positive 3 halves. So y prime of 4 is negative 1 to the, I would do 4 to the 1/2 and then the 3 afterwards. 4 to the 1/2 is the square root of 4, which is 2. Cubed is 8. So that's your slope. You got a point in the slope. Y minus 1 equals negative 1/8. X minus 4, just leave it. Don't do extra work. That's good enough. Don't change the slope in yourself form. Why? Okay, number 3 is like one of these long problems. So you gotta work it all the way out. So first thing, I started taking off points, so I might take off even more on the retest. You gotta write the limit. If you're not at the limit, you gotta write the limit. If you don't, I'm gonna write it. Equals. All this work should be connected together. So the first thing we're gonna do is we're gonna plug x plus 2h into x, which means anything that's being done to x has to be distributed to this. And that was a mistake a lot of people made. So it's going to be 3 over 2 parentheses x plus 2h plus 1. You really should put parentheses. Minus, now we're just going to plug x in. So it's actually going to look exactly like it is. All over 3h. This is all about the work. Make it nice and neat. Be thorough. Okay. Now, we want to get this all in one big fraction. So this is going to be, I could write it, I guess. H goes to 0. Haven't taken the limit yet. you take it right at the beginning, you're going to get 0, 0, which is indeterminate form. In this case, it's a hole in the graph, and we're actually trying to get rid of the hole, the way we do in simpler ones. So this is going to be 3 over 2x plus 4h plus 1 minus 3 over 2x plus 1 all over 3h. Now, you got to give this guy a 2x plus 1, top and bottom, 2x plus 1, top and bottom. So it needs a 2x plus 4h plus 1, top and bottom, 2x plus 4h plus 1, top and bottom. And on the top, you should distribute it. And here you're going to distribute the negative. So this is going to be 6x plus 3 minus 6x minus 12h minus 3 all over 2x plus 4h plus 1, 2x plus 1. And this I'm going to now change it to 1 over 3h, multiply it by the reciprocal. Now the whole point of this is, this h right here is what is the whole. And the only way to get rid of the whole is to cancel it out with a factor of h out of the top. But the only way you can factor h out of the top is everything has an h. Any non-h terms really should go away if you've done it correctly. 6x minus 6x, 3 minus 3. That's what's left, right? H's cancel. I mean, you can even reduce this to a 4, negative 4. So now we have limit as h goes to 0 of negative 4 over 2x plus 4h plus 1, 2x plus 1. And now we're going to plug h equals 0 in. And that term's going to get away. And it's going to be negative 4 over 2x plus 1, 2x plus 1. Or negative 4 over 2x plus 1 squared. Or if you're really doing extra work, which I wouldn't recommend, negative 4 over 4x squared plus 4x plus 1. Any of those. But that's what you need to do. Long way, gotta show your work, right? Gotta write the limit every time. I gotta be able to follow your work. It's all about the nice work. Graphical limits. You gotta be able to get limits off of pictures. All these dots should really line up with nice values. Okay. So the value of f at 8 is just the value of the graph, which is here, 0. There's a jump. The limit as x approaches 8. Well, as you approach 8 from both sides, they both agree that it's going towards 3, even though the value of the function is not 3. Limit can be something else. As we approach 7 from both sides, one side's going to infinity, one side's going to 4, does not exist. The two sides have to agree. And if either side's going to infinity, we're going to say it does not exist for two set of limits. As we approach 3, they're both going to negative infinity. And I think on my solutions, I wrote negative infinity. That's really not appropriate. Does not exist. If it was one-sided, yeah, let's just say negative infinity or whatever. Limit as we approach infinity, that's called in behavior. It's going towards this horizontal asymptote of 1. F, we're approaching 3 from the right side, and what's the derivative? So as we approach 3 from the right side, the function is going to negative infinity. The slope, though, is going to positive infinity because it's a positive slope, right? I mean, if you look at the slope on the right side of 3, it is going up from left to right. It's a positive slope. G, as we approach infinity, the derivative is flattening out. It's going towards horizontal asymptote, so it's getting flatter and flatter and flatter. It's going towards a flat line. It's going towards a 0 slope. H, true or false? Limit as x approaches 0 of f of x equals f of 8. Well, it's just the value of both sides. What's the limit as we approach 0 of f of x? It looks like both sides are going towards 3. The value of f of 8 is 0, which is false. Just show me what the values are. Show me if it's true or false. Those problems are quick. Not a lot of work to show, but you want to get them all right. Now we have a bunch of limits. No L'Hopital's rule. unless I tell you to. I'll tell you right now that you could predict the kinds of problems I'm going to want L'Hopital's rule are usually ones that are going to give you 0 of 0, and the ones that have holes. So we're going to say 7 and 8 should also do with L'Hopital's rule, in addition to a non-L'Hopital's rule problem. Otherwise, everything else is non-L'Hopital's. First step is to always plug a number in and see what happens. So this is 2 times negative 2 cubed minus negative 2 squared. So it's 2 times negative 8 is negative 16 minus 4 is negative 20. So sometimes substitution works. I mean, usually it's kind of boring. Like number 6, as x approaches 5, left side of 5, what's the value of 7? It's still 7, no matter what. It's horizontal line. Number 7, let's plug 2 in. We get 8 minus 8 over 2 minus 2 equals 0 over 0. So this is good to show that it is an indeterminate form, and to also tell you that there might be a hole in the graph. This tells you what you should do, okay, by plugging the values in first and seeing what happens. So if we're going to factor the hole out, we're going to cancel, we got to factor this. So this is the difference of cubes, x minus 2, x squared, 2x, 4. The pattern is first thing squared, last thing squared, and middle multiply them together. Same, opposite, always positive. So, and you guys know you get x minus 2 out. I mean, you can use synthetic division and take it out. Don't need rational root theorem, that's for sure, even if we forget how to factor this. Now we're going to plug 2 back in. We're going to get 4 plus 4 plus 4 is 12. Now L'Hopital's rule, which we might just go ahead and write. By the way, in a free response problem, you have to sort of defend the use of it. So L'Hopital's rule, we got the 0, 0, so we're going to say equals limit as x approaches 2. We need this in your work. I took off points for people that didn't put it. I'll take off more next time. Derivative of the top, 3x squared. Derivative of the bottom, 1. I should really see top and bottom. And then you're going to plug 2 in. And you're going to get 12. Same answer. Should be the same. So you're going to need both of those sets work on the retest. Number 8, if we plug 2 in, we get 8 plus 4 minus 12 over 2 minus 2 equals 0 over 0. Indeterminate form, hole in the graph, L'Hopital's rule. So to get the whole of the graph, this is a cubic with only 3 terms. I have to use, I'm not going to use the rational root theorem. I already know what root I want. I'm going to factor out x equals 2. That's the root that goes with this. So synthetic division 2, 1, 1, 0, negative 12. Drop the first number down. 2, 3, 6, 6, 12, 0. You should get a 0 at the end. Now what this gives you is this gives you the limit as x approaches 2 of x minus 2. And these are the coefficients of what's left over, x squared plus 3x plus 6 all over x minus 2. This should be in your work. That's the hole in the graph. We're going to reevaluate it, plug 2 into what's left. 4 plus 6 is 16. Now L'Hopital's rule equals the limit, still have a limit, should be in your work, it should be in your work, of 3x squared plus 2x, derivative of negative 12 is 0, all over 1. If I plug 2 in here, I get 12 plus 4 is 16. No surprise, same answer. So those are the kind of problems. You probably have like 2 that you have to do 2 ways. Okay, next one, we're approaching 3 from the right side. So we're plugging 3 in here, and so we're getting 6 over 0. But it actually matters. Is it and so we know the answer is going to some kind of infinity. Is it positive or negative? Well, it depends on the bottom. It's something, it's not really 0, it's something really tiny. Is it positive or negative? Well, we're approaching 3 from the right. It'd be like 3.0001 or something. Minus 3 would be a little positive number. So it's going to positive infinity. I mean, this is, I would at least write this little plus here to show me. It's not really 0. It's something really tiny. Number 10, if you plug 4 in, you get 16 over 0, so it's definitely going to some kind of infinity. There's a positive or negative. Approaching 4 from the left, so that'd be like 3.999 to the left of 4. So this is going to be a negative. This is going to negative infinity. Okay, those are pretty quick. 11, if we go to infinity, top's going to infinity, bottom's going to infinity. So we're going some kind of infinity over infinity. Okay, that's something good to write. Positive infinity over positive infinity. Right? Now in here, this is the dominant term, and this is the dominant term. So, really these terms go away when we go to infinity. And since these are the same power terms, it's really just going to be the ratio of the coefficients. So this is going to end up being the square root of 2 over 4, which is the square root of 1/2, which is 1 over the square root of 2, which is root 2 over 2. Okay, I messed up. 2 over 8, which is 1 over 4, which is 1/2. And it's positive, right? Positive infinity and positive. It should come out positive. This one's going to infinity. It's going to go some kind of infinity on top, some kind of negative infinity on the bottom. Positive or negative. You better get a negative answer. Okay? This is good to write. This tells you what you're dealing with. You're dealing with end behavior. You got to look at the dominant terms. This dominant term on the top is 3x, but you need absolute values to ensure it comes out positive, because it should. Even if you plug negative in for x, get squared, it becomes positive. Take square root, it get positive. Even if you plug in negative. Now these are the same ratio, so it's really just going to be the ratio of their coefficients. So it's going to be 3 over negative 3, which is negative 1. Okay. For 13, plug infinity in. It's going some kind of positive infinity over some kind of positive infinity. Better get a positive answer. Indeterminate form. We can do a L'Hopital's rule, but I'm not asking you to do that right now. Plus, you wouldn't want them. It'd be harder in this problem. Look at the dominant terms. You could even circle them like I do to show me. This one's dominating this one. The whole thing, this is blown up. This is going to positive infinity. Now, technically, the answer does not exist. But in these end behavior things, I want you to write infinity or negative infinity. I want to know the behavior of it. Okay, this one, if you plug 0 in, this is what sine of 6x over cosine of 6x. If you plug 0 in, you get sine of 0 is 0, sine of 0 is 0, cosine of 0 is 1, 0 over 0. This is a hole. This is a graph with a hole in it. We can do L'Hopital's rule, but you guys aren't good enough at these derivatives to want to do that, and I don't want you to do it anyways. I want you to use that pattern, limit as x goes to 0 of sine of x over x equals 1. And if it isn't there, make it happen. The cosine isn't the problem. So I'm going to rewrite this. Split everything up. So I have the sine of 4x in its own fraction times, now this is going to keep change flip, you're going to multiply by the reciprocal. The cosine 6x ends up on top, and the sine 6x ends up on the bottom. Now, the cosine doesn't matter. That's going, cosine 0 is 1. Don't do anything with that one. But this guy needs an x, but this one does too, so they balance each other out. This one needs a 4, that one doesn't, so I need to balance out with an extra 4 up here. This one needs a 6, that one doesn't, so I'm going to balance out with the extra 6 down here. Now that's going to go to 1, that's going to go to 1, and you have 4 over 6 left over, which is 2/3. That's the kind of work I'm looking for. 15, piecewise functions. I need to see the two separate sides. So we need to do the limit as x approaches 3 from the left of f of x, which is going to be the limit as x approaches 3 from the left of, on the left side, it is that. X squared plus 5. And you plug in positive 3 in. Square is 9 plus 5 is 14. And then we do the right side limit. Limit as x approaches 3 from the right side, superscript plus of f of x equals, more specifically, the limit as x approaches 3 from the right. of x squared plus 5. So this one's weird. The left and right side end being the same, but usually they're different. 9 plus 5 is 14, and since these are both the same, the limit exists, and it is 14. So since they both agree, the overall limit can safely be concluded as 14. That's the work to back it up, though. Number 16, if you plug h equals 0 in, you get 0 over 0. You can go through the whole thing, try to get rid of the whole, Pascal's triangle, binomial theorem, super long way. I don't want you to do that. If you do it that way, you make any mistake, I'm not giving you credit because you chose to make it worse. You should be thinking this is the definition of the derivative, right? So the quick way is to say, well, what function are we taking the derivative of? And this one is x to the 5th power. This is where the x's. This is where the x's go. Okay, so if there's a number there, that means we're going to evaluate it afterwards. So what's the derivative of that? Just, the memorized shortcut way, 5x to the 4th. And then you're going to plug 2 into it. 5 times 16 is 80. Now be careful, if there's a number in front of both of these, then that's part of the function. And that should be right here. The 17, if you plug infinity in, this is going to positive infinity over positive infinity in determinate form and behavior. It should be a positive answer. Now, this is always going to be between -1 and 1, right? Which is really nothing compared to infinity. This is the dominant term. This is the dominant term. They have the same coefficients. They have the same degree, so it's just a ratio of the coefficients. But it might be good to say, hey, look, this guy's always beginning. This one's not really going to a certain value. It's just bumping up and down, up and down, up and down. Right? These are the dominant terms, though. That one really doesn't matter when you plug big numbers into it. All right, position time graph. Add one like this on the test. Add one on the pretest. We've had a lot of them. So, car initially at rest. That means its slope is 0 and its position is 0, so it should be a flat slope. Accelerates rapidly. It's getting steeper quickly until t1 seconds. So flat slope, getting steeper until t1. The car then maintains its speed. It means it's not changing. Speed, velocity is the slope of the position curve, so it should maintain it now. It depends on what my line looked like when I hit this, but there should be no bend or corner here. It should look like it goes perfectly into it, and this part's a straight line. Now my graph's just going to be super tall, but yours doesn't have to be as tall. Then slows and finally stops at T3. So it's going to bend back downwards to a 0 slope gradually. T3, it says at T4, so it doesn't do anything between T3 and T4. It's a flat line. You should see nice little dots here. T4 begins to return home steadily, increase rate 3/4 of the way home. 3/4 of the way home. So, I mean, my graph, 3/4, if it was right here, would be right here, but it's a little taller, so it's going to be like another maybe 1.5 squares. I don't know. Let's see. This is 6 squares. 3/4 of 6 squares is 4.5 squares. So now 4.5 squares down. 1, 2, 3, 4.5. So kind of like somewhere around here. So 3/4, it car suffers engine failure and comes to a stop. So this should be bending downwards. And then a little quick maybe bend upwards to a flat slope. Because it stops, it should have a slope of 0, and this graph shouldn't have any sharp corners or anything. So something like that. And this just depends on the size of your graph, Okay, position time functions. So I wouldn't necessarily count these to be gravity or even think about them as gravity, but here's a position function. We shouldn't have any negative time on these. This does have units for seconds, but it doesn't have units for length. So you could say units and units per second, but anything time should be seconds. Find the height at time 3. So height and position are the same thing. Okay. So this would be S of 3. Label your work. Show me what, plug it in. So 9 times that's going to be 90, 50, 144 plus 360, 384 plus 6. So that's going to be 240, 246 is the position at 3. So we could say units. All right, average velocity. So V average is just the slope of the position curve. It's just S4 minus S1 over 4 minus 1, which is the slope between the endpoints of S's, not velocity. Not velocity, not velocity. That's average acceleration, which is not what we're looking for. So we got to figure out what's S4, what's S1. I mean, maybe I need to do a little work right here. S4 would be negative 16, 4 squared plus 128 times 4 plus 6. 16 times 16 is negative 256. This is 256, that's 512 plus 6, that's 256, that's 262. 262. And S of 1 would be negative 16 plus 128 plus 6. So that would be 118. Okay, so 262 minus 118. Borrow from that. 12 minus 8 is 4. 5 minus 1 is 4. 144 over 3. 1 plus 4 plus 4 is 9. 3 goes into 9, so 3 should go into this. So, I mean, you could do 144 divided by 3, 4, 12, 24, 8. Do a little long division, 48 units per second. The average velocity. Instant velocity is just the actual velocity. So v equals s prime, the derivative of s, which is negative 32t plus 128. So we're going to plug 3 into this. See how I'm labeling my work? Vs prime, then v3. I need to see that. So it's negative 96 plus 128 is 132 units per second. It's the velocity at 3. Did I make a mistake? 32, not 132. Okay, during time interval for which velocity is greater than 0, or a combination of things. The main thing is you gotta do line checks. If there's 2 things, you gotta do 2 separate line checks and compare them to each other. So where's the velocity greater than 0? Well, we gotta take the velocity equation, which is s prime, which is negative 32t plus 128, and we need to set it equal 0. We can do line checks. Factor out 32. It's gonna be minus 4. T equals 4. Critical point. Velocity, label your line check, label your work, label your line check. Is it open dot? Test the value. T is 5. I guess we should have kept that. So that's false. True. Watch out for bounces off the graph. So that's the answer. I mean, you could say negative infinity to 4, but we don't want any negative time, so we should say 0 to 4. But it is true at 0, not at 4. Time 0 is a valid time. We don't want negative time though. Find the particle's velocity when the height is when you're going to find the time, and then you're going to plug it into the velocity. So the hard part is probably finding the time. So you're going to take the position equation. say equal to 20. And then move everything to one side. Minus 214 equals 0. And then factor, can we take a what? 2 out, negative 2, 8t squared minus 64t plus 107. I think that's all we can do. So I think we gotta do a quadratic equation, quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be 64 plus or minus over 16 square root. So what's 64 squared? 16, carry the 1, 24 is 25. 0, 6 times 4 is 24, carry the 2, 36, 38, 6, 9, 10, 40, 96. Minus 32 times 107, 14, carry the 1, 0, 21, carry the 2, 34, 24. So what's 40, 96 minus 34, 24? 2, 7, 6, 672. This is just kind of messy. Okay, 64 plus or minus the square root of 672. So we could take a 2 out, 336. Take another 2 out, 168. Another 2 out, 2 out, 84. 2 out, 42. 2 out, 21. 3 times 7. Pair of 2's, pair of 2's. So this is 64 plus or minus 4 root 42. So we could divide 4 out of everything top and bottom. 16 plus or minus square root of 42 over 4. There's two answers, 16 plus square root of 42 over 4 and 16 minus the square root of 42 over 4. I don't want the negative ones when I'm done, but this is about, it's between 36 and 49. It's about 6.5. Either way, it's going to be positive, right? This is about 22.5. This is about 5. And this is about 2. They're both positive. So now you got to plug them into your velocity equation. There's 2 times that are possible. 0 would be possible too if it came out. And if you do the work, it's, it's a little messy. If we plug in 16 plus square root of 42 over 4, velocity equation was negative 32 over 16 plus square root of 42 over 4 plus 128. That gives you 8. That gives you negative 80, 48, 128. That's 842 plus 128. Gives you negative 8 square root of 42. We can have negative velocities. Can't have negative time. So that's one of your answers. Units per second. If you want units, this last one should have been seconds. The other one, velocity of 16 minus square root of 42 over 4, very similar works. Going to be negative 32 times 16 minus square root of 42 over 4 plus 128. So it's going to be 8. So it's going to be negative 1, negative 128 plus 8 square root of 42 plus 128. So we get 8 square root of 42 equals the velocity at 16 minus square root of 42 over 4. All right. I got a little messy. So, I mean, I would say this corrective seems very much like the test result. Yeah, I feel like we're getting pretty much all the same kinds of problems mostly, and about the same numbers of them. Derivative, continuous differential, both or neither. So continuous means that the y values are equal. So we could plug 2 in. 4 minus 2 is 2. 6 minus 1 is 5. These aren't equal, so it's definitely not continuous, which means it can't be differentiable, and it can't be both. It's got to be neither if we're looking to be done quick. It's not continuous. Differentiability requires continuity. It's not continuous. If you were to test for continuity, you take the piecewise derivative, and then those two pieces should equal each other. So if you plug 2 in, you get 2 times 2 minus 1 is 3, and 3 equals 3. And some people might mistake that as being differentiable, but because it's not continuous, it can't be differentiable. To want to improve the power rule. Well, I'm not going to make you, but we've done it before. The power rule is that if you take the derivative of something to a power, you move it in front and decrease it by 1. So that's what we're trying to prove. So the definition of derivative, we can say, well, f prime, limit as h goes to 0 of f of x plus h minus f of x over h. This is a common approach, right-sided approach. So in this case, it would be x plus h to the n minus x to the n over h. Limit should still be there. And if you plug this in, you get 0 over 0, which is an indeterminate form. So you need to sort of expand this with binomial theorem, which is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So the thing you'll notice is that the first coefficient is always 1 no matter what. It's x to n, h is 0. The next term is always the next power. Is the power on the original graph. This would be an n. X n minus 1, h to the first. Plus, well, the rest of it's going to definitely have at least h squared and higher, right? And then you still have this minus x to the n all over h. Now that's a 1, that's positive x to n and minus x to n, and they cancel each other out. Remember, we're trying to get rid of the whole, so now we can factor an h out of everything on the top. This is going to be n x to the n minus 1 plus h to the first with a bunch of other stuff over h. That's the hole in the graph. Plug h equals 0, and that goes away. N x to the n minus 1, which is the power rule based off the definition of derivative. Okay, 22, find the derivative. Okay, well, f prime of x equals 4x cubed minus 18x. Pi is the number, so it goes away. Do not say plus 2 pi to the first power. Next one, I would distribute all this out first. So it'd be 6x cubed minus 8x squared plus 15x minus 20. Combine like terms. 6, actually, they're all combined, so we can go ahead and do the derivative. Power rule. 18x squared minus 16x plus 15. The derivative minus 20 is nothing, 0. This one I'd rewrite as 2x to the negative 3/4. 4 through is a 1/4 power. Rules of exponents for multiplying. So then you can do the derivative of this is 2 times negative 3/4 x. Subtract 1, bring you negative 7/4. So we have, you rewrite it negative 3 over 2x to the 7/4. That's fine. You're at negative 3 over 2 fourth root of x to the 7 if you want. Okay, next one. We had a couple like this in the test. You guys should love these. These are quick and easy. Essentially, we're estimating f prime 4 using this definition of derivative, but we're estimating it. So there's no limit because we're estimating it. So we're going to plug 4 in. H value is here, is 0.1 this time. So that's what goes in there. This is the first thing I would do. Just write it all out. I appreciate that. So that's going to be f of 4.1 minus f of 3.9 over 0.2. F of 4.1 is 25. F of 3.9 is 10 over 0.2 is 15 over 0.2. Now, some people have trouble with this. It's the same thing as 2/10, right? So multiply by the reciprocal. So that's 150 over 2 is 75. Came out nice. This is the kind of, now, the most appropriate thing is to put a wavy equal sign right here. It's an estimate, but no limits. So f prime of 4 is approximately f of 4 minus f of 4 minus 0.1 all over 0.1. So this is f of 4 minus f of 3.9 over 0.1. And f of 4 is 15, 3.9 is 10. This is the same thing as 5 over 1/10. The same thing as 5 times 10 over 1, which is 50 for the estimate. We're not actually using limits. Limits is for exact. Now a couple sketches of derivative graphs. So horizontal asymptote on the right side looks like it's going on the right side, vertical here and here. So we should have a vertical asymptote of 2. We should have a horizontal asymptote along y equals 0 because it's going flat. So I would say it's going to 0 here, and then there are positive slopes that are blown up, so it's going to look like that. This is an open dot though. Over here, it's a constant slope, down 1 over 1, -1. It's a -1 slope, so it's going to be down here. Now the graph keeps going, so I guess we would just put an arrow over here. Otherwise, if it stops, we put an open dot. Always put open dots on the edges. This one's going to 0, and it's blowing up here. The slopes are all positive. So this is what it looks like. I can see some people wanting to draw it down here, but the y values are going negative, but the slopes are all positive slopes, left, right, it's going up. Okay, here's another one. Slope looks like it's 0 here, going to 0 here, vertical here. So we need a vertical asymptote x equals -2. Looks like it's going flat as we go to infinity, so horizontal asymptote. I start with open dot here. We're at 0, and these are all positive slopes. It's getting super steep as you get to the right side of 2. So this is what that chunk of the graph looks like. Over here, these are all negative slopes, so it is going down. It's all below, and it's getting super negative. And this is a constant slope of -1, down 1 over 1, down 2 over 2, however you want to do it. It's a -1 slope from 0 to flat, constant slope. And then this slope right here is 0 from 2 to 3. Now, these are all open dots unless the two pieces connect smoothly. Well, there's your graph. They have to connect, and they have to connect smoothly. But that's it. Prepare for your retest. Be ready. Let's do better than we did last time. Let's master limits. It's the foundation of calculus.